Lecture 13. The Quantum Observer Effect in Consciousness studies the veil between observer and observed trembles at the edge of perception. Welcome to the 13th crossing of our threshold into the mysteries of consciousness. I am your guide through these nebulous realms where mind and matter perform their ancient dance. Today, we venture into perhaps the most enigmatic territory yet, the quantum observer effect and its shadowy relationship with consciousness. What if I told you that reality itself might be suspended in a state of ghostly potential until a conscious mind brings it into being? That the very act of observation might not merely reveal reality, but create it. The quantum realm whispers secrets that shatter our comfortable assumptions about the nature of existence. In previous lectures, we glimpsed the peculiar behavior of reality at its most fundamental level, where particles exist as probability clouds, where causality blurs, and where the classical rules of our macroscopic world dissolve into quantum strangeness. Today, we peer deeper into the abyss between mind and matter, exploring a question that has haunted physics since the early days of quantum theory. What role does the observer, perhaps consciousness itself, play in the manifestation of physical reality? Our journey begins with the infamous double-slit experiment, a deceptively simple arrangement that unveils one of reality's most perplexing enigmas. When particles pass through two slits, they create an interference pattern as if they were waves passing through both slits simultaneously. Yet when we observe which slit each particle traverses, the interference pattern vanishes and the particles behave as discrete entities. The mere act of observation appears to collapse a world of quantum possibilities into a single definite outcome. But what constitutes an observation? Is it the interaction with a measuring device, or does it require a conscious observer to witness the result? This mysterious collapse of the wave function, the mathematical description of all possible states a quantum system might occupy, represents perhaps the most profound paradox in modern physics. Before measurement, reality exists in a ghostly superposition of possibilities. After measurement, only one possibility remains. Heisenberg's uncertainty principle tells us there are fundamental limits to what we can know about reality. The more precisely we determine a particle's position, the less we can know about its momentum. But is this limitation merely technical, or does it reveal something deeper about the relationship between mind and matter? The measurement problem haunts the foundations of quantum theory like a specter that cannot be exorcised through mathematics alone. When exactly does the wave function collapse? What triggers this transition from the quantum realm of probabilities to the classical realm of definite outcomes? This is where consciousness begins to cast its shadow across the quantum landscape. If measurement causes collapse, and measurement ultimately requires observation, then what constitutes an observer? Can an inanimate measuring device truly observe without a conscious mind to interpret its readings? The Copenhagen interpretation, championed by Niels Bohr and Werner Heisenberg, suggests that quantum systems remain in superposition until measured by a classical device. This pragmatic approach sidesteps the deeper questions by treating the quantum and classical realms as fundamentally separate domains governed by different rules. But others have dared to venture further. The von Neumann-Wigner interpretation places consciousness itself at the center of wave function collapse. According to this view, it is ultimately the conscious observer who triggers the transition from quantum possibilities to classical reality. Consider the quantum Zeno effect, a phenomenon where continuous observation prevents a quantum system from evolving. Like the mythological Zeno's arrow that never reaches its target, a constantly observed quantum particle becomes frozen in its state, unable to follow its natural quantum evolution. Is this not reminiscent of how our constant observation of everyday objects confirms their solidity and persistence? Perhaps the stability of our macroscopic world is but an illusion sustained by our unceasing conscious attention. Even more bewildering are delayed choice quantum eraser experiments, where the decision to observe which path a particle took can be made after the particle has already passed through the slits. And yet this future decision appears to retroactively determine whether the particle behaved as a wave or a particle in the past. Does this suggest that consciousness might transcend our linear perception of time? That the relationship between observer and observed might be more intimate and mysterious than our conventional frameworks allow. The tendrils of quantum weirdness have inevitably reached into theories of consciousness itself. Sir Roger Penrose and Stuart Hameroff proposed the orchestrated objective reduction theory, suggesting that quantum processes in neural microtubules might give rise to consciousness. According to their view, the collapse of quantum superpositions within the brain's cellular architecture creates moments of conscious awareness. Each collapse represents a moment of truth, a discrete instance of subjective experience emerging from quantum uncertainty. Physicist Henry Stapp proposes that consciousness emerges from quantum measurement processes in the brain. In his quantum mind theory, your attention and intention actively shape which potential neural patterns actualize from quantum possibilities. Each conscious choice involves the collapse of a vast array of quantum probabilities into a single experienced reality. Your mind is not merely responding to a predetermined world, but actively participating in its creation moment by moment. Philosopher David Chalmers, known for articulating the hard problem of consciousness, has considered whether quantum mechanics might offer a bridge across the explanatory gap between physical processes and subjective experience. If consciousness indeed interacts with quantum systems in a fundamental way, perhaps the hard problem isn't so much solved as dissolved. Maybe consciousness and matter are not two separate domains requiring a bridge, but aspects of a deeper reality where the observer-observed distinction breaks down entirely. But what empirical evidence might support these speculative connections between quantum physics and consciousness? Recent studies have sought quantum signatures in brain function, particularly within microtubules, the cellular scaffolding within neurons. Some research suggests that quantum coherence, the maintenance of quantum superpositions, might be possible in the warm, wet environment of the brain, contrary to earlier assumptions. Could the brain have evolved to harness quantum effects for the emergence of consciousness? The evidence remains tantalizing but inconclusive. Quantum coherence has been observed in photosynthesis and bird navigation, suggesting that biological systems can indeed exploit quantum phenomena. But detecting quantum effects specifically related to consciousness presents formidable challenges. How does one design an experiment that bridges the objective measurements of quantum physics with the subjective nature of conscious experience? This intersection remains one of science's most formidable frontiers. The quantum observer effect raises profound philosophical questions about the nature of reality and our place within it. If consciousness indeed plays a role in actualizing potential realities, what implications might this have for our understanding of free will? Perhaps our choices are neither completely determined nor completely random, but represent genuine moments of creation, instances where consciousness collapses quantum indeterminacy into definite outcomes that weren't predetermined. The measurement problem in quantum mechanics and the hard problem of consciousness might be reflections of the same underlying mystery. Both involve the relationship between the objective physical world and subjective experience. Both resist explanation in purely materialistic terms. Some philosophers have suggested that this connection points toward a form of idealism, the view that mind, rather than matter, is the fundamental reality. If consciousness collapses the wave function, perhaps consciousness is not a product of physical reality, but its foundation. Others maintain that quantum effects in consciousness can still be understood within a materialist framework. Perhaps quantum processes simply provide the physical mechanism through which consciousness emerges from brain activity, mysterious, yes, but still ultimately physical. The boundaries between physics and phenomenology, between the study of the physical world and the study of subjective experience, are becoming increasingly permeable. The observer can no longer be neatly separated from the observed. As we draw our exploration to a close, we find ourselves at the edge of knowledge, staring into mysteries that might forever elude our complete understanding. The quantum observer effect suggests that consciousness and reality are entangled in ways we're only beginning to comprehend. Perhaps the most profound implication is that we are not passive spectators of an independent reality, but active participants in a universe that requires conscious observation to manifest its potential into actuality. I leave you with this thought experiment. Imagine a quantum particle in perfect superposition, existing in all possible states simultaneously. Now imagine your consciousness gently touching this particle through the act of observation. In that moment of contact between mind and matter, potential crystallizes into reality. Are you merely witnessing what was always there, or are you participating in creation itself? Perhaps in this question lies the key to understanding both consciousness and the quantum world, not as separate mysteries, but as different facets of the same ineffable truth. In our next lecture, we will explore the phenomenon of quantum entanglement and its possible relationship to connected consciousness. Until then, remember that in the dance between observer and observed, neither leads and neither follows. They create each other in an eternal moment of becoming.